What's going on, guys? Back again with another THERMO Boys video. Today we're going to be going over a Chapter 6 problem for a refrigeration cycle. Hopefully you guys can see this up here, but I will read it off for you. A refrigeration cycle has a coefficient of performance of 5 and is sized to remove 100 kilowatts of heat from a building which is kept at 23 degrees Celsius. This device rejects heat to an energy reservoir at 33 degrees Celsius. And as we know, a refrigeration cycle, we're taking heat from a cold source and moving it to a hot source, or a warmer source, using work. So the first question we're looking for here is how much power does this device require? And with the given information we have, we will start by using the equation for a COP of a refrigerator is going to be the desired effect over the work input. In this case, we have one equation, one unknown. So our COP here, we can plug in as 5. Our desired effect is to remove 100 kilowatts of heat. So you put the 100 kilowatts on the top here. On the bottom, we're looking for the power. So in this case, the power is the rate of work. And if you solve this equation out, we get the work is going to be equal to 100 kilowatts over 5, or 20 kilowatts. All right, now moving on to part B. B asks, what is the rate at which heat is rejected from this device? In a refrigeration cycle, we know work being equal to QH minus QL. Rearranging this equation to solve for QH, we get the rate of work plus QL. Plugging in what we know, we just solved for the rate of work to be 20 kilowatts plus our 100 kilowatts of heat being removed. If we solve that out real quick, we're going to get 120 kilowatts. All right, guys, moving on. Part C, does this device satisfy the second law? So here we know that it is a refrigeration cycle. We're moving heat from a cold reservoir to a hot reservoir. And we do have work being done on the system. Therefore, yes, this system satisfies the second law. All right, moving on. Part D. Is the system consistent with the Clausius statement? Well, the Clausius statement basically says that it is impossible to construct a device that operates on a cycle that the only effect that it has is moving heat from a cold reservoir to a hot reservoir. So, as we're being a refrigerator, we know that we do have heat being moved from a cold reservoir to a hot reservoir, although power is going to make this statement true. So yes, our problem does and is consistent with the Clausius statement. One more part. What is the maximum temperature the high temperature reservoir can have while the COP does not change and the second law is not violated? So what we're looking for basically is the greatest value of TH in the equation COP, or refrigerator, is equal to TL over TH minus TL. So we know we have 5, we can sub in for our COP of the refrigerator. We have TL is going to be 23 degrees Celsius plus 273 to change it to Kelvin. Same thing on the bottom, TH minus 23 plus 273. And solving this out, we're going to get TH is equal to 355.2 Kelvin, or subtract 273, and we get 82.2 0.2 degrees Celsius. Alright, that's for today, guys. If this video did help, hit that like button and subscribe to the channel for future videos.